Okay, Ishkaran,
Um,
you can start.
just open up the same repository like yesterday.
And kindly refresh the page again.
For your reference, I'm sharing it on the chat even. Uh, who all knows like what fine tuning of an LLM actually means by? Anyone knows what fine tuning is? Like what actually fine tuning of an LLM is done and how it is done or why it is done? Like anyone knows about this thing? That is an open house question. Anyone any idea? Okay, so basically, if you consider any of your LLMs, whether it's ChatGPT or Llama or Mistral AI or anything like Grok even, all of these models, they are already pre-trained models. And when we have to train these models for some specific use case, whether that specific use case is a particular task or a particular data set, what we do is we fine tune those models to our particular use case. Like, for example, if I want to train ChatGPT to tell me more about medical knowledge instead of like common knowledge, if I train that ChatGPT model over a medical data set, it will be telling me about that medical knowledge instead of just telling me random things. Okay, so this is how it's done, and there are different methods for fine tuning. First, first of all, earlier, like before the this app named as Llama Factory came up, we used to write approximately like around 1,000 to 2,000 lines of code, and right now we just utilize this Llama Factory, which is the easiest way till now to have a finding done. And I'll show you how a fine tuning will be done using Llama Factory. And if anyone asks you how you're gonna do it, this is the best way till now to do a fine tuning done for approximately all the models that exist out there. Like if you can see over here, like I'm gonna share this link with you guys so that it's easier. Oh, sorry. Look, this is a link for Llama Factory. And if you see over here, like your every model is there. Like DeepSeek is there, Falcon is there, Gemma is there. Then your GPT-2, your Kimi, which is a recent model, and Lava, which is again a recent model over here. Llama 3, Llama 4, Llama 3.2 Vision, Mistral AI, then your Phi, Quinn, Star Coders. All of these, which are the famous models, they can be fine-tuned over here. And not just this, fine-tuning is basically done on the basis of like a particular kind of data set, and Llama Factory has made it this easier that we can define our own data sets over here, whichever data sets that we want to define as. Like if you come to just the data folder over here, you see over here you have n number of data sets, and not just this, you can define your data sets in the JSON file with the link, and that will be helping you to define like from where you are fetching that data and how the data can be used for fine tuning over here. Like if I show you the identity JSON file, See, just again. Mm, These are specific data sets basically. Uh, yeah, if I, yeah. See, if you come over here, see, this is graph, like whatever the data set name is, where it exists, and what is the formatting for the same, and what are the columns that it exists in. This is just a, master JSON file where you can actually make the edits and fetch the outputs. Not just this, if you come over here, you can define your Hugging Face URLs as to like this is the Hugging Face URL, and just define a particular URL over here, and you can utilize all of the data set for your fine tuning. Okay. And does anyone know like what all kind of fine tunings that exist over here? Like anyone who has heard about like DPO, reward modeling, like anyone knows what different kinds of fine tuning all exists. Okay. So basically, there is this thing named as, if you come over here, there is full training, full fine tuning, then there is freeze tuning, then there is LoRa, and then there is QLoRa. Like these are the types of approaches that occur. And like if for your reference, I'll suggest like if you guys can write it down because this is used in your day-to-day life, even like where you have to do which kind of a approach you have to apply and why you have to apply that kind of an approach is as an interview. And you need to know it on a tips because when you come across such an easy resource, you need to know you cannot go on hit and trial method that whether freeze fine tuning is coming up, LoRa or QLoRa or PPO or DPO you're gonna use. So just write it down if you guys want to. Full fine tuning is basically when we update all the model weight using the new task that we have to do. Okay. And this full fine tuning is done for a specific case when we have, you know, a huge data set and the computational resources that we have, they are huge. Like by huge, I mean minimum of 200 or 300 GB of GPU. When you have this much of a resource, then only you can consider doing a full fine tuning because this will update each and every neuron of a transformer model of a GPT model and then will train on the specific new task and it will give you that full fine tuning done. Okay. So this is the like this is known as full fine tuning. And but since I told you like it's computationally very, very expensive, and if a data set is not huge, the whole of the model will overfit and it will lead to crashing of the model and not working out properly that you want to work upon. Okay. Then there is freeze tuning. Freeze tuning is basically we freeze certain n number of layers of the transformer model and fine tune the remaining of the layers. Okay. Like supposedly, if a GPT model consists of 10 layers, like 10 neuron layers, we just freeze five of them and just retrain the remaining five of them. That is known as layer freezing. This is done, when early layer captures the generic features and the later on layers, which we are fine tuning, we we are training those layers for task specific layers or we are it basically kind of it's a combination of the task that we want to do it and a generic thing. Okay, but one thing before all of this fine tuning, make sure the data set that you are training upon, whether you are fetching it from Hugging Face or you are using your own data set, make sure about one thing that it's totally structured, not unstructured. Because if it is unstructured, then your model is going to crash at all moments of time and it won't work in a way that you actually want it to work. Like for example, like when I was working with one of my interns, what happened was we had a huge data set, and data set was like approximately around like 6 to 7 GB of text basically. But the main major reason was that the text files, since it was all text, it wasn't working out properly out there. Okay. So what we did was we did fine tuning on the unstructured data. We trained the model on the unstructured data, and then we had to use an fine tuning. Instruct fine tuning is basically telling GPT like how we can actually question those things out. So basically, we did as layer freezing on top of a layer freezing again. Understood till now? Like if you guys have any doubts, let me know. Till now, if you guys have any doubts, drop in the chat box. Let me know. Um, Proper structure, like what do you mean? Like, okay, I don't have the reference right now, like where I use a word. Okay, I'll come. Okay, I'll just summarize all of the things that I've taught right now. Um, I'll come to the what is the difference between transfer learning and freeze fine tuning. Okay, that I'll come to that later on. In order to like summarizing, basically, there are different kinds of fine tuning that is done. Fine tuning is basically done when we have to, have a pre-trained model, and we have to train that model again over a specific task or a data set. And that task or data set is decided by us. Like, for example, if I want my ChatGPT model to tell me more about how this, to tell me more about medical knowledge, which ChatGPT isn't trained upon right now. If I train it on a medical QA data set and ask it to tell me like more about like why I'm gonna use a paracetamol or why this antibiotic is used by me, any of the number of questions, then that becomes a specific task for a ChatGPT. That is known as fine tuning. There are different kinds of fine tunings. You have supervised fine tuning, which is known as SFT, then that's reward fine modeling, and each of this fine tuning approach will is divided into four parts. That is full tuning, freeze tuning, LoRa, and QLoRa. Okay, so full first, I'm going to tell you like what is the difference between full fine tuning, freeze tuning, LoRa, and QLoRa, and then I'll tell you about what the approaches is and what is the difference between the approaches. Okay, full fine tuning is when all the layers of a ChatGPT model, they are updated in a proper format. Like for example, all the layers, they are trained end to end, just like you are training it in the scratch thing. Okay. You have to utilize full fine tuning only and only when you have a huge data set and you have a huge amount of computational resources available with you. And my advice is that full fine tuning never happens unless until your use case is very, very unique. And if a use case is very unique, you won't be having enough, data set for full fine tuning. Even if you're ticking off all the requirements, I suggest you find a different way out because full fine tuning is going to take days to just, get a proper thing done. And you might not even know whether it will turn out to be good or not. And then it comes up is freeze tuning. Freeze tuning is basically when we freeze particular layers of a ChatGPT model and or of any of the llama model, or you can say as any other model, like which we are training on, we freeze those layers and we train upon the remaining layers. Like supposedly, if it's a 10 layer model, I'm gonna freeze n number of layers in the starting, which can be defined by us. Okay, and then we use the remaining unfrozen layers to train upon the task that we need. Okay, it is like freeze tuning can be known as like partial fine tuning even. And one of the disadvantages of freeze tuning is basically it has a limited adaptation. And what I, mean by limited adaptation is that it will be both working as a generic model even, and it is going to work as for a specific task that you want it to work. Means it's not going to be that good, but yeah, it's going to get the task done. Okay. Any doubts till now? Okay. So basically, now we'll come to LoRa and QLoRa. LoRa, whenever, like, okay, so now there is a thing named as adapter in an LLM. Anyone knows what an adapter in an LLM actually refers to? Okay. Have you guys heard about a fine tuning named as PEFT? Like anyone you come across while reading any blogs or research papers, you see that, we fine tune the model in the terms of PEFT. PEFT is basically parameter efficient fine tuning. Okay, no, got a point. So basically, there is this thing known as adapter based fine tuning wherein we insert a small trainable adapter modules between the layers and we only train these adapters. And under adapters, we have this thing named as LoRa for which we're gonna work, okay? Like which is utilized over here. What LoRa does is that it updates the adapters basically refers to as large weight matrix and we insert these large weight matrices in a small rank matrices that are trained upon. Okay. So this is basically kind of, a new method of fine tuning wherein we just update the, minute or small number of parameters and base model that we have of an LLM remains frozen. Only these adapters get updated. This is known as, LoRa. And the reason why we came up with LoRa was it's quite efficient in terms of like we can fine tune the parameters here and there, and it is gonna give us a fine tuned model with a very less GPU resource. Okay, so this is what actually LoRa refers to us. Any doubts till now? Like what exactly do you mean by LoRa or QLoRa or sorry, have you understood like what is full fine tuning, full tuning, freeze tuning, and LoRa? Okay. So now we come with okay. So adapters. If I explain adapters again, like what do we mean actually by adapter? Adapter is basically a weight matrix. Uh, okay. So tell me one thing. Do you know what weights in a LLM model is? Like anyone? Yeah. Perfect. If you know by what a adapter, like what a weight is. Weight are basically kind of the numbers that we assign to what each layer will be or weightage of each layer is, right? Adapters are basically, it's a small trainable network module, okay, which is inserted inside a large pre-trained model. You can say, well, it can be a matrix, it can be a small neural model, it can be a weight even. So this is what exactly is an adapter. Like it's in the easier terms, this is what adapter actually means as. Any doubts, anyone? Okay. So moving on to QLoRa. QLoRa is basically a quantized version of LoRa. Okay. LoRa की full form is low rank adaptation, and QLoRa की full form is quantized low rank. Um, okay, Akshay, can you just unmute yourself and ask like what exactly the doubt over here is? Okay. First, let me complete.
Just in the question. Okay, so sorry. You complete it.
Yeah, what I do
So
is
sorry.
I complete all of these approaches, and once I'm done, I'll ask what a doubt is. Okay. Okay, so basically, QLoRa is quantized low rank adaptation, wherein it's a combination of like quantization of a model and LoRa that we did earlier. Okay. So this is what a QLoRa is actually used for. The in this, the major difference is that the base model like in LoRa, the base model is just frozen. In this, the base model remains frozen and it is quantized. What I mean by quantized is like, it can be having a 4-bit precision, it can be having an 8-bit precision, it can be having a 16-bit precision. Okay, have you guys heard ki a 4-bit precision model is basically like okay, for example, Llama 3.18b has an act if you download the whole model, that whole model is somewhat like 10 to 11 GB in download size. But if you use a 4-bit quantization of a model, it's gonna be like just 4 GB or 5 GB over here. That is what means by quantization, that we reduce the size of the model. If I have to show you like what exactly is quantization, this is LM Studio. Okay. You will just like Olama, this is known as LM Studio. Just like for your reference, I'm gonna show like how a quantized models look like. See, this is Llama 3.2. Okay. And if you see over here, any model having GGUF file at the end, it's going to tell you like how much quantized it is. Okay. Like if you see over here, it is Q to quantized. There is 2-bit K quantization, extremely low fidelity. 3-bit, 3-bit, 3-bit. Okay. As and when you increase your model size of the model in GBs increase, and your quantization will become increased in order में होती है. Like there, it's directly proportional out there. See, 4-bit K quantization, you might have 6K and 8K. The difference is 8-bit quantization will be having 20 GB of, utilizing 20 GB, and a 2-bit is having just utilizing 7 GB, which is like, you know, a very less amount of resources. Okay. That's basically the major difference in quantization over here. Okay. So that is what like quantization does, and this is what, quantization is helping out. In LoRa, we just used to, insert the LoRa adapters, that is small trainable layers. We train only on the LoRa. and parameters, and then during inference, we combine LoRa outputs with the frozen model, right? This was the workflow of a LoRa thing, like how LoRa fine-tuning happens. In QLoRa, we just come across another, you know, step which is done in the starting, which is we quantize the base model. We quantize it to 4-bit precision using, NF4 quantization, and then we insert the LoRa adapters. Then we train only on the LoRa adapters, and then we combine those LoRa outputs with the frozen base models. And once the combination is done, this will give us a whole fine-tuned model. Okay, so any doubts? Anyone? Okay, so now I'm going to tell you, first, okay, go ahead, Akshay. Anyone having any doubts? You want to take 2 minutes, recapitulate like what all I have told you about, and then we will be moving to these approaches, like what exactly these approaches are. Okay. Hmm. Okay, so are you guys done with recapitulating like what we have done till now? Okay, got it. Perfect. Hmm. So tell me one thing, like when you were doing your machine learning projects or machine learning in Thapa Summer School, you were told that there are different kinds of machine learning. Like there is one is supervised machine learning, one is unsupervised, one is I guess your RL supervised, that is reinforcement learning, right? What is the difference between a supervised machine learning and an unsupervised machine learning? Like anyone can just unmute yourself and tell me about the difference over here. Sure. And I want to hear this thing as an answer from you. Otherwise, it will be no sense to move ahead to these approaches. Guys, any one of you can unmute yourself and tell me the answer. Okay, what do you mean by limitness or unlimitedness in terms of processing? And this is not the, actual answer even. Why? Because the difference is a major one, but it's very, very easy. Come on, guys, tell me.
Hello. So,
Yeah.
actually, we were taught that supervised learning had two parts under it that were classification and regression, and the second
Agreed.
and the second part was unsupervised learning, where the clustering portion was taught.
Hmm.
And classification, we use algorithms to predict the values. Category means I mean to say that there are some sort of values that we try to predict. And in the
Nope,
regression,
nope, nope. Basically, the major actual difference in supervised and unsupervised machine learning is not on the basis of algorithms, it is on the basis of a data set that you utilize. The supervised machine learning consists of the labels that we actually know what the output is going to look like. The labels, which basically we refer to as. In unsupervised machine learning, we don't know what the output is going to look like. Okay. And it requires the algorithms to discover the patterns and structures of its own to find out what is actually the label is going to be looking like in unsupervised fine tuning. Okay. So this is the basic difference in supervised and unsupervised machine learning. Okay. And moving on to the approach over here, you have seen over here supervised fine tuning. This over here, the supervised fine tuning. This is classifies super like what it means by SFT is that when we utilize this SFT when you have a data set which is curated by human written, like it's not existing and we have curated our own data set. So okay, and we have the labels as to what we're training upon. Okay, like we have the input and the output pairs. And in terms of LMs, what input and output refers to as is what is the question I'm going to ask and what's the response to the question that we want to give it to. Like, for example, if a training data set consists of who is Eishkaran and what's like the answer for Eishkaran is given, then the model will be trained upon that and it will be able to answer who is Eishkaran. Otherwise, it won't be able to answer. Okay. So that is what we actually refer to as supervised fine tuning in in the case of LLMs. Okay. And then it comes your reward modeling, PPO, DPO, KTO, ORPO, SIMPO. Okay. These are all reinforcement learning fine tuning. Anyone knows what actually reinforcement fine learning is? ये तो पता होगा यार, ये सबको पता होता है, reinforcement सबको पता होती है. Tell me what it is. I don't want to hear like you whether you know it or not. Tell me like what exactly is reinforcement learning. Okay. Reinforcement learning is basically reward modeling. Exactly. It's kind of reward modeling wherein you can say as like I refer to you know reward modeling as something as mm, learn from the punishments that you get. I don't need the you know answers directly from the Google searches. Okay. You can keep those. If you have knowledge about it, then fine. Otherwise, I'll tell you about it. Okay. Yeah. So basically, like for example, it's a reward modeling. They're going to be consisting of two things. One is a reward and one is a penalty. Okay. If the model performs according to what we actually want it to perform, we give it a reward. And if it doesn't, we give it a toffee penalty over here. Okay. So that it learns from its mistakes and perform better. This is that is known as reward modeling. Okay. So this is how it is done. Okay. Basically, as I'll say as rewarding penalty. जैसे होता है ना कि बच्चे को अगर डांट डांट के कोई चीज सिखा देते हैं तो सेम वे दिस reinforcement learning works. And in this reinforcement learning, we will be having RLHF. RLHF is basically kind of uh, reinforcement learning, human with human feedback. Like when we train a reward model from human feedback, that is, you know, the reward model is based on the human feedback. Like I tell the model that whether this is correct or not. This PPO and DPO, like direct preference optimization and proximal policy optimization, these are fine-tuning models based on the reward models, and it it is kind of an RLHF based models. Okay, and for your KTO is scale uh, penalized basically, and I guess it exactly KTO is not exactly RL type, but it is like we consider it under RL type, but it exactly isn't an RL type. Why? Because in this we do token level optimization using KL regularization. Okay. And similarly, you have ORPO, you have SIMPO, and then reward modeling even. Like all of these are kind of reward modelings only that we consider. Some might be having high complexity, some might be having low complexities, some might be using human as a feedback, some might be using the existing data sets as a feedback. Okay. Uh, this is basically the approaches that we have, and this is how it is done. This is what an LLM actually is, and how we're going to find an LLM is. And if you get any other LLM other than, the already existing models over here, you have to write 2,000 or 3,000 lines of code and do LoRa full fine tuning on your own. But, you know, just in case you're getting, these supported models, you are in luck and you can just, stand out of the crowd and just go over here and fine tune these models in a very faster way. Okay. So, guys, I hope that all of you might have the links opened up or to these collab notebook. If not, take a minute and we'll work upon this collab notebook right now. And once you are done opening up, go to manage sessions. Sorry. No, everything will be done from the code itself that is written over there. Go to view resources, change runtime to T4 GPU, unsave it, and connect to T4.
Class, this is very important. Go to runtime again. Ishkaran,
Yes,
एक बार
sir.
दोबारा बताओ.
Go to view resources. Okay. You will find change runtime, change to T4 GPU, and then connect to T4 GPU.
There is one more option. टॉप पे जाओ, रन टाइम पे क्लिक करो. इसे कैंसिल कर दो. ये रिसोर्स को भी कैंसिल कर दो. टॉप पे जाओ, टॉप पे रन टाइम टैब दिख रहा है आपको. ishkaran यहाँ पे नहीं, टॉप पे लेफ्ट में रन टाइम मेन्यूज.
भाई रन टाइम के टाइप में आएगा
रन
वो
टाइम
रन
चेंज रन
टाइम
टाइम
पे आप
टाइप.
जा रन टाइम के टाइप से आता
रन टाइम चेंज रन टाइम टाइप. नीचे नीचे, हाँ।
Like change runtime.
सर यहाँ पर भी यू कैन चेंज
Yes.
योर सेटिंग टू TPU, T4 GPU।
We want T4 GPU.
चलो कंटिन्यू करो।
A1 has done this. Okay. So, not what we're gonna do is we're gonna just fetch these things. Like if I explain it to you, like each of the lines, what is happening over here, we move to the content folder of Google Colab. We make sure that there doesn't exist any folder named as Llama Factory. Using the same link of I told you git clone, we utilize git clone to download the whole of the Llama Factory onto Google Cloud. What I mean by depth one is when you come to this repo, you have branches over here, main branches and latest branches. Like they always exist, these things. So depth one basically refers to as we want the most stable release of Llama Factory, not the unstable ones. Okay. We installed the depth one and then we move to Llama Factory into the folder of Llama Factory. Then we do an ls over there. And once that is done, we pip install torch, that is PyTorch, and bits and bytes. Bits and bytes is basically that library which will help us in quantization. Okay, which I told you, like 2-bit quantization, 4-bit quantization, and 8-bit quantization. That is what it helps in. So just click on Shift Enter, come to this cell, click on Shift Enter, and run an anyway. It will take some time, so start doing it side by side. And it will ask you to restart a session. So restart when it is asked.
So class, this is just we are running the notebook, so please make it fast। ईशकान थोड़ा सा जूम आउट कर लेना अपनी स्क्रीन को।
Just gives us a pop-up of restarting the session. Just click on this, and a session is going to be renamed again. Once it's done, just run the next cell, and it will help us to determine whether we got our GPU running and installation is done or not. So you'll get a folder named as Llama Factory over here itself in your content files. Okay. Everyone done? Till here, everyone is done with it?
ईशकन थोड़ा स्क्रीन को जूम आउट करो यार, थोड़ा काफी फॉन्ट छोटा आ रहा है, कंट्रोल प्लस प्लस करो।
Oh, okay. So
बस बस बस।
everyone is done till here? Okay. So now, basically, the next code, that is this one, it's gonna help you to determine whether, like, what kind of a JSON file that exists and how we're gonna write in that JSON file. Okay. This is just, a mandatory step which is gonna be helping to, fine tune models over here. Okay. And this is just gonna, if you go, just click on shift enter, it's gonna redirect you to the directory named as content slash llama factory. And now there are two methods through which fine tuning can be done using llama factory. One is using command line tools, and another one is using a web UP, like web UI basically. So if you want, I can show you the web UI of llama factory. And if you want, you can use that web UI part even if you feel that's comfortable. But I don't find that comfortable is why the reason why I don't use is because it is very, very compute heavy and it takes a bit of time to load, and there are too many parameters that you have to define before running it. Like if I just add a text. So just I'm going to share these two commands over here in chat. Click a new code cell and paste these two you know commands and run it up. It's a web UI. I'm going to enable web UI for you, and I'm going to tell you like how it looks in the backend. Everyone do it till here and run this web UI on your laptop so that you have a knowledge about like, what is and how it is done. See, you will get something named as the public URL. Click on this public URL over here. Running on public URL comes up. So just click on it. Basically, they are using Gradio. Gradio is just like a Streamlit. Like we used Streamlit yesterday. Gradio is just another form of Streamlit, you can say. Yep, exactly. It's a GUI. And it's basically, it was developed that so that, even a non-tech person who is having no knowledge of how to fine-tune LLMs, they can fine-tune their own LLMs using this thing. Just explore this, like what do you have a language model over here, like whatever languages you want to choose. Okay. Just ignore this. This error might come up. Then you have models over here, like which all models exist and which models you want to train. Like supposedly, if I click on, a smaller model, mm, for example, I define DeepSeek over here. Like it gives you a warning even like you're using a non-instruct model, please fine tune it first. So we might use a 7 max instruct model, which is the one that might use what kind of all the model paths and hub name, that is whether you're getting it from OpenMind or Model Scope or Hugging Face, it gets defined on its own. Okay, then um, there is something named as fine tuning method that we want to utilize. It is already defined as LoRa over here. You want to do a full fine tuning, you want to do a freeze fine tuning, it's your choice. what is the checkpoint path that you want to define? Checkpoint path is basically whenever you do a LoRa fine tuning or freeze tuning, a new um, model has to be generated at what point and where it has to be generated. The path to where it has to be generated, that is the checkpoint path. Okay. Quantization. Do you want to do some kind of quantization or not? Since we are doing LoRa, so quantization is not required. If we want to do quantization, then what kind of quantization we have to do? BNB, HQQ, EETQ. Like these are all different formats. Chat template basically refers to as there is always a chat template that exists for each of the LLMs out there. Like if you see over here, DeepSeek has its own chat template, Gemma has its own, Llama might have its own, Lava will have its own, Mistral is gonna have its own. Chat template is basically the prompt, the original prompt on which the LLM was trained. Okay. I don't know what ROP is. I have never used it. I have never used, this booster. I don't know what it. What stage we want to train on, like whether you want to do a supervised fine-tuning, reward modeling, PPO, pre-training, KTO, whatever. What is the data directly to it? What is the learning rate that we have to define? What is the data set path that we want to use? What all data sets we have to declare over here? What are the epochs that we have to work upon? What is the gradient we have to work upon, and what is the maximum samples that we have to test against? I'll explain like what gradient maximum samples is later on even. What is cutoff length? What is batch size? Gradient accumulation, validation size, everything. You can define all of these parameters and you can work upon all of these parameters whenever, wherever it exists. Then evaluate and predict, like once you're done with the training, you need to, evaluate and predict like how good your model is for performing. So you can evaluate on the on the basis of a device memory, like what's the device memory that I have on that basis, like everything. And once you are done evaluating the model, you can chat with the new model that you have created. Okay. And you can export this new model, whether you want to export to Hugging Face or you want to, that is optional over here, but you can, export it there or you can download it on your local computers even. Understood till over here? Any doubts? Take 5 minutes and go through this UI, okay, and understand like how it's being done, what it's being done. Okay, just take 5 minutes and understand this thing out. Once you're done understanding like how it is being done and what's it being done, you can, just drop in a message that we are done. So we'll move to the command line tools. Everyone understood? Guys, anyone having any doubts? Just put in the chat box if you have any doubts, guys. Okay. So once you are done with this, just click on pause and the gradio will just stop. Okay. And it is gonna end over here. Now, we can actually go to command line method, which is the method which I actually like. And this is what I'll say you guys should use because you are a tech person and not a, non-tech person. Okay. Um, okay. So what we do is you first read through all of it and try to, I'll say, find what all you know in all of these things, like except for stage, do train, model name path, dataset, and template, because template is what I have told you right now, and fine tuning type. Okay. Except for these three or four, or I'll say these are five. Except for these five parameters, just uh, think what all the other parameters are. And if you know any of the parameters and you want to answer, I'm open to hearing it, like whatever you know about. Hmm. Anyone who knows logging steps, warming steps, epochs, what all you know, just answer, unmute yourself and answer. Like I'm open to hearing it. Anyone wants to take you can answer it out. Anyone knows anything? Or do you want me to explain all the parameters right from start? Guys, please answer. Okay. So I'm gonna assume that you guys don't know. And I'll explain all of these parameters. Stage over here, we have defined as SFT, which is, supervised fine tuning. If we change this to PPO, DPO, RL, anything that we want to do according to the use case that we have. This do train is basically whether we want to do the training or not. If we do it as false, it won't do the training. We have to keep it as true. Model name or path. We have to use, since we have to use, we can say as the Hugging Face path can be the model name path. So it is the Hugging Face path basically. The data set is exactly basically, alpaca, alpaca en demo. Like this is data set name, and it is fetched from the identity data sets. These are two data sets that it has utilized. Since it's using a Llama 3 as a model that we have to train upon, so the template will even be Llama 3 template only. What kind of fine tuning we are doing? It's LoRa. Now we have mentioned LoRa target as all, means that we are applying all LoRa adapters to linear layers, like apply LoRa adapters to all linear layers. Basically, what I mean by this is every layer with matrix multiplications, like that neurons consist of matrices. With every layer having a matrix multiplication will get LoRa adapters over there. Okay. And those LoRa adapters tagged will be trained over here. And that's why the LoRa target over here is named as all. Okay. Output directory where I want to save this output over here. And the output directory is llama 3 underscore LoRa. Then it comes per device train batch size. Since we know the data set is huge, so uh, and we know this thing that large models are going to utilize a lot of memory. We divide into small batches, and the batches is two. Okay, like in a batch of two and two, the model is going to get trained. Then graded accumulation steps, which is referred to as like it accumulate gradients over 4 steps before updating the weights. Basically, uh, you can say as mm, when the GPU is limited, the gradient for each of the layer is updated like for 4 steps, like 1, 2, 3, 4 steps. And then after these 4 steps, we'll update the gradient. And it depends upon like what your GPU size is, and you can change these steps to us. Okay. And uh, there is this formula, like you can calculate the effective batch size. Effective batch size will be basically 2 into 4, that is 2 into the gradient accumulation steps, which will give you the effective batch size. Okay. So 8 can be the effective batch size which we can have. Okay. Then there is LR scheduler type. LR scheduler type is basically what kind of annealing we have to do, like what kind of learning rate has to be there over a period of time. And in our case, it's cosine learning rate. Okay. Then at what steps we have to do the logging, because we need to know when will the model crash, or what's the loss we are getting at after every step in training. So logging steps is 5. What is warm-up ratio? Anyone knows? Warm-up ratio is basically, let me recall. Warm-up ratio is basically learning rate that we have. You can say that, but it's based on learning rate. Like example, like if we have a learning rate of 1E5, like in this case, it's like 5E minus 5. So the warm-up ratio is 0.1. That is for the first 10% of the total steps. That is the total steps that are going to exist. So the first 10% will be the warm-ups. This will help to stabilize the training at the start. And this will, that peak curve in starting will be, not there, and it will stabilize all of that curves. Then you have save steps, like how and when to save the steps that you want to, like after each 1,000. Then learning rate, everyone knows. Epochs, everyone knows. You know, these are common ones. Max samples is basically um, for like how many samples from each data set we have to use for like validation. Like I want to use 500 examples as a test set or 1,000 examples. It depends upon the size of the data set we have. Max grad is gradient nomination, like gradient norm, which is one, of course. And LoRa plus is basically an improved version of LoRa. Like what is the ratio that we keep? And FP16 is basically 16-bit floating point precision, I'll say. Okay, and report two is basically if you want to see the curves, like how the training is happening in the curves and all that, we can enable these report two, and it will show us like how the curves are happening on WAN-DB. Okay, so you have to define all of these arguments in a JSON file, and then only you will be able to train a model. Okay, from 1,000 lines of code or 2,000 lines of code, you are back to like I'll say 20 lines of code. And once you run this, it will save a JSON file with all these parameters, with all these parameters that you have. Once this is done, I'll just show you. Just click on, this thing, shift enter, and you will be able to do it. And it has started training a new model even. See over here, model.safe.tensors. It's downloading the model right now. I don't know whether it will be able to download the model because the model is going to be huge. Just do shift enter. And for your reference, if you come to the content over here on the side, we got a new file named as train underscore llama3 JSON. If you click on this file, see all the arguments that we wanted. All of these are the arguments through which the model is getting trained upon. A1 understood. Anyone has any doubts while the model is fine tuning or it's being done, they can go on and ask right now. Like any of the doubts that you have till now. I'm open over here right now to any doubts that you guys might have. If not, then let's wait for this to be done.
Okay, Eishkaran, we are fine tuning the models. So
Yes, sir.
end of the day, हमें क्या देखना है? What is that? हम कर क्यों रहे हैं? पहली important चीज.
So, finding is done when we have any specific task in our mind that we have to fine tune for. Like, for example, ChatGPT is not trained on a medical data set, and medical data set is a domain which is expanding these days, and we want to develop, a model which can answer the medical queries of a user. So we just fetch the medical data set, we fine tune on the medical data set, and it is able to answer those medical questions like when to use Dolo 650 or why is this antibiotic used for which disease it is used. Like we can ask those medical questions over there.
Okay.
It can be fine tuned to any use case that we have.
ठीक है. नेक्स्ट क्वेश्चन ये है कि अब वैलिडेट कैसे
Mhm.
करेंगे कि मॉडल की परफॉर्मेंस अच्छी है या खराब है आफ्टर फाइन
Once the
ट्यूनिंग.
fine Once the fine tuning is done, like whatever kind of fine tuning we do, we can chat with the model. Like, for example, after the fine tuning is done, we infer the model, we attach the adapters on the model, and then we chat with the model and get to know whether the answers that it is coming from the model, whether they are in a proper format or not. If the model is not giving us in a proper format, like format, what I refer to as the response that it is giving is not structured. And if the response is unstructured, we will get to know that the model is not performing good.
ठीक है, इसको मैं दूसरे तरीके से मैं पॉइंट आउट करता हूँ. लेट्स सपोज मेरे पास
Hmm.
अभी इस समर स्कूल में नियरली 200 स्टूडेंट्स हैं
Okay.
एंड आई ऑर्गेनाइज वन हैकाथन
Mm-hmm.
मैंने उनको डोमेन दे दिया, मेडिकल डोमेन आपके पास है, एंड
Mm-hmm.
यू फाइन ट्यून करो मॉडल्स की।
Okay.
अब एवरीबॉडी ब्रिंग देयर ओन फाइन ट्यून्ड मॉडल। अब मुझे उन सब मॉडल को कंपेयर करना है, तो
Mm-hmm.
वो मैं कैसे करूंगा? एंड
Okay.
सिमिलर टू कैगल की, जिसका फाइन ट्यून मॉडल बेस्ट है वो लीडर बोर्ड पे टॉप पे आ जाए, जिसका नहीं है वो नीचे आ जाए।
Hmm.
तो ये कैसे करूंगा मैं?
ओके, सो बेसिकली यहाँ पर हम लोगों ने यहाँ पर एक हमने डेवलप किया था मैक्स सैम्पल्स एज एक पैरामीटर डिफाइन किया था। दिस मैक्स सैम्पल्स is basically 500 as a data set that is from the training data set. We are removing these 500 samples, and the model will be trained on the data set except for these 500 samples. And this 500 samples is basically a test data set for us. You can
हम्म।
hide this max samples or testing data set, and you can test against this how good a model is performing or how good a model's response is on these 500 samples. If this doesn't like help you out, there are benchmarks which exists, and each for every use case we have a benchmark. We can use those benchmarks and determine like how good a model is performing. Like for example, there is match eval benchmark. Like you have this match bench, which is a benchmark which is used for evaluating how good a model performs, LLM performs on mathematics, and
ओके।
they have their own leaderboards out there.
ओके।
Yes.
सो इसमें इसको इस हैकेथन ऐसे छोटे से कंपटीशन को ऑर्गेनाइज करने में हेल्प करना हमारी।
Okay, so like for example, if we have an SNLI data set, we can have a SNLI benchmark. You click on this, you get a proper benchmark, like what all it's a existing, like how the benchmarks will be there, and what all parameters and what all the accuracies are be coming out. This is how the benchmarks exist. And we can define like we want to see the test accuracy, train accuracy, we want the parameters, everything can be defined. So guys, it's learning now. It will take approximately 30 minutes to fine tune. Okay. And all these parameters which we had defined, they are running right now. And the difference between RAG and fine tuning is RAG is done when you have a very, very limited number of resources, like you have a one PDF file or two PDF files. And fine tuning is done when you have the data set as, in GBs, like you have 5 or 6 or 7 GBs of data set, then you use fine tuning. RAG can be done on this much amount of data even, but RAG will start to give unstructured responses, and it won't be, though as structured as what a fine-tuned model is gonna give. Guys, anyone having any other doubts? And is everyone being able to run the model till here? And guys, if you have better resources, rather I'll suggest that there is this program that is coming up from Google right now. Let me share you guys the link with it, um, if it's possible. My Yep, sorry. My whole of LinkedIn is filled with it. I'll just share it if you guys. Yep, this guys. Since all of you are Google, like all of you are right now students itself, so I'll suggest that you register for you know Google Gemini. Google is offering a pro version of Notebook LM to India, and it's like actually worth 19,000 rupees. You'll get 2 DB of Google Drive storage for free. You'll get all these accesses for free. Just register on this thing, and you will get the access to all of these things for free right now. And apply on this model, like apply on this curriculum. You don't need to register for, you don't need to give your credit cards, you don't need to give your anything. It's free for 1 year. So register on this and you can work across. And let me tell you one thing, this notebook LM can summarize 1,500 to 1,600 pages long PDF for you. So you've got your end minute exam prep ready with you. Register on this if you want to, guys.
So you must have academic email ID, so through which you can register. क्यों Eishkaran? Yes, no?
Yes, sir. Yes. You need to utilize the Thapar IDs if you have. Like you just go to services.share ID, put in the school over here, email address for school basically. Like I'm graduate now, so my IDs won't work. So that's why register yourself if you guys have it. Okay, let me try. I might have. I can utilize a different one. If you guys want to, you can register right now. It will open to, your IDB platform. The Hubber will be having a different one. You can utilize, go over here and just log in. See, my username cannot be identified, and same is for um, my this thing for Thapper. So you can just click on this and verify your own credentials, and it will be working fine. Anyone having any doubts, guys? And one more thing, while you are working, while the code is running, um, go to Google, go to lmstudio.ai and download this on your own laptops. I'm gonna explain like what exactly this is after the second half, after we are done with this fine tuning part. Start downloading in the side by side method. Yep. Understood, guys. Anyone having any doubts? Guys, I'm open to any doubts you want to have. I'll say 10:45, we can take a small break and download this platform. And in the background, just keep on running this code. When you're back from it, I'll explain like what exactly we have to do after this. And then I'll just shift to what LM Studio actually is and how it is effective.
ओके ईशकरण, एक ब्रेक लेते हैं.
Okay, so guys, everyone, I guess it's almost 80% done for me. We have still 6 minutes going for this, but I'll just introduce you to LM Studio. Once you are done installing LM Studio, it's gonna look something of this sort. I'm sure I'm gonna make this easy for you. LM Studio is basically like yesterday we heard about Olama, right? LM Studio is just like Olama, but I'll say sometimes it's better than Olama. And personally, I use this as a, my way of chatting with local LLMs instead of Olama. Why it is better? See, first of all, it has an direct linking with Hugging Face, like whatever model you have on Hugging Face, you get over here. Whether it's like whatever model you name, you get over here. Okay. You can download the model in different quantizations, whether it's your 2-bit quantizations, 3-bit quantizations, 4-bit, 5-bit, 8-bit, like I told you. If I want to go in for instruct, I can get an instruct 1B parameter model even. I can get a 3B parameter model even, 8B parameter model even, and sometimes yes, I can get a 72B parameter model even. If I show you, I might get that. Okay. So, wait a second. I just need to click on show all. See. Um, yeah. See, this is 32-bit quantized model and it's having 32 GB of um space. That's how it goes. Okay. And not just this, once you are done installing a model over here, like if we install a very short model, like a small one, I'll just do it for you guys. And I'll be really quick for this. Fee, like Fee is a Microsoft's model, and it's small. Okay, like it's quite small. We just click on download. It's just showing down over here. Okay, and it starts to get download over here from here. And the major part is that you don't have to chat. You don't have to write a code like any other models over here. You just have to load a model. It will be loaded directly into your RAM. You can change the context window, you can change the temperature, you can change the tokens to generate, CPU threads, everything from here. And that model will work the same way as you want it to work. And you can just directly ask the model to chat with any of the prompts that you want. Okay. And this is not the best part for this. The best part comes in Playground and local server. Playground is basically sometimes you might have multiple models. Like supposedly, like Sir said, I want to compare multiple models at the same moment of time for a particular prompt. what I'll do is I load multiple models. Like I load multiple models. Like for example, I load Llama, I upload Mistral, I load Fee. I want to get a prompt for each of the models. And this is what multiple models gonna help me do. Load one model, load two models, multi-model prompter, and it just get done. Okay. And now comes the major part, which is this thing. This is basically using OpenAI's key, but instead of using the OpenAI's actual key, you will be inserting the base URL as localhost and API key as LM Studio. And this will actually make your laptop or PCs that you're working upon a server, and people all across will be able to use your model as a server and chat across it. Like once this is done, I'll just show you how, you can actually mess around with it. And your models will be stored over here and you can, just delete and store it again. And this is the actual way the things have to be done also. Okay. So let's just wait for this to get completed. Till the time this is done. Um, no, you don't need to install any of the LLMs right now. I'll just show you how it's done. And once it's done, you can like, go around in your own codes and all that and just work upon it. No, I'll say that just wait for a minute. Download your LM Studio and open up your, I'll say, Visual Studio codes if you have. Okay, so guys, you can see that our model is trained. We got the epochs as this. We got the total flaws, total loss, to train runtime, samples, steps, everything. We got a whole new model trained on alpaca dataset, and it's stored over here. If I show you llama 3 underscore LoRa, which is the output directory which we had declared over here. And if you open up this, you will have a GUF file or H5 file, I guess. Yep. All the checkpoints, Raptor configuration, the training logs, everything is over here. And this is the checkpoint which is going to help you to actually, you know, adaptive model safe tensors, which is going to help you to load over any of the model and fine tune that model. Once the fine tuning is done, what we do is we infer the model. That is, we can chat with the model if we want to. Otherwise, we leave it as it is. Like if I show you, if it's able to run over here, that we can do it. Yeah, I think we will be able to do it. See, so okay, so I alpaca is a normal data set, insta data set. So I don't know what prompt we should give usually, but we can talk with it, I guess, a bit. Yep. See, user, hey, assistant, hello, I am Llama 3, an AI assistant developed by Llama Factory. How can I help you? And this is actually trained to what your new data set is. So you can chat with that. And yes, one thing more, you can merge the LoRa adapter that you have with the base model of Meta and call it your own model and upload to Hugging Face wherever you want to do it. Like this is a code for the same, but I won't be able to run. Why? Because I have 12 GB of RAM, and this actually needs 18 GB of RAM to be done for an 8B model to be done, at least 18 GB. So this thing would be happening, but you can actually do this, merge the LoRa adapters and work upon. So my suggestion to you guys is that if you have servers, like your own servers, or since you now have Google Cloud, like Pro versions, so you can um, work upon different kinds of fine tunings. Try PPO, try DPO, try reward modeling according to the resources that you have. And this, I suggest you one more thing. Open up a Kaggle and try over there. Same Kaggle files will be working out over here. Same command line tools, everything will work out the same manner over there, and you have a better Kaggle is having a better resources, so utilize it on Kaggle. I guess Kaggle offers you like around 30 GB of RAM, so it can be done very easily over here. I'll just confirm this. Yep, Kaggle offers 30 GB of RAM, so easily your 8B model can be fine tuned very easily over here. Okay. So this is all about how fine tuning is done. Got it, guys? Anyone having any doubts? Let me know. Any doubts, anyone? Anyone else like having any doubts? Okay. So we move to LM Studio. Let's check it out. Like, what's the progress status? It's almost done. Yep. Let's just wait for another 1 minute. Yes. And by the time, just open up your Visual Studio Codes. So the models are already. Now what we are gonna do is we're gonna do the simple thing. Go to AI chat over here. I'm gonna just load the model. That is the free one. Just a second. Um, not possible, I guess. Strange. Um, my bad, guys. Just I'm out of storage right now for my RAM. Yep, I am out of storage for my RAM, I guess. That's why it's not able to load. Unused is 10. Just a second. Wait. Okay. So guys, I tell you one more thing. What you do is you just have to do one thing. Once the model gets loaded over here, I don't know why it's not loading. Might be the platform or VRAM use is not happening. Like it's not complete. Just load the model over here. Okay. You just click on this and load the model on your disk. And once you are done loading the model, it will create a, you know, like model will be loaded over here and it's going to tell you like how much RAM usage is there. Okay. And how much RAM is being used and what's the CPU percentage that you're having right now. And once that is done, just click on Start Server and you copy paste the code that is in AI Assistant, you know, Python, or you can use the chat one. Just copy the code and paste it over here. That is in your VS Code, and then you can chat with the code in the same manner like we were doing yesterday. But the major part is you can do much better things with this LM Studio, like fine tuning your own models than working with Olama. This has better use cases. And had this not been an issue right now, I would have asked you guys to like um I would have asked you to just like, hit your Visual Studio Codes and hit the server that I have created right now. And once that server is created, I would have you would have enjoyed like this thing. And try and get this done if it's possible. Um, we use this a lot for this. I don't know why it's not happening. Like, just let's wait. Like, once this model gets loaded, let's hope that this one gets loaded on the chat. But this is what an LM Studio looks like, and this will help you to, brief about this thing. Not phone. Just 2 minutes more. I guess this is not a correct model, I think. Well, let's wait for Llama to get downloaded. I prefer using that instead of, you know, it's almost done. Sorry for the wait, guys. Working. Got it. Okay. So basically, what we do is, like, make it interesting for you guys. Wait. I have the code written, I guess, and this will help you guys. Yep. So if you see, yep. Yeah. So I just gave the prompt, always answer the question in rhymes. Okay. And the user has to introduce itself. Basically, this is the question and this is the prompt that's given in background. Okay. And the temperature is kept as 0.7. Since I'm asking answer in rhymes, so it's always gonna be hitting the thing like, um, something in creativity it needs. So that's why the temperature is set as 0.7. If I keep it as 1.0, this one get more creative. Okay. And um to see the prompt, like what is user being introduced as. I am a machine. I'm here to stay. My name is instructor in a fun way. I'll answer the questions with a smile and cheer. So come on, let's get started, my dear. So that's why he introduced itself as a machine, and it is answering like what it is and who it is in a rhyming format. Okay. So this is how this actually works. And if I, you know, show something different, like if in a gradient format, if I am able to do it. Let me check if I'm going to do it, able to get it in gradient. Let's hope it works. This one. Yep. I think it will work now. Yep. It might work out. Just a second, I need to correct this code. Sorry. I'll share this link with you. So I think we can, guys can talk with it. Yep. So what I do is, I'm dropping this link in the chat box. Okay. Everyone, use this link and you can, chat in the same manner the way I am chatting right now. Okay. And whatever you do, I will be having logs of whatever prompts you're giving to it, and I will be able to track like what is done. So this is how I'm hosting a model on my end, and you are able to use it on your end. Yes, this is hosted on my right now. So just do one thing. Use this as a method of um like this is the last thing that we'll do for today. Just have an interaction with this chatbot, and then we'll be done with for today. Anyone, any other doubts you have for today's session, you can ask me. And once you are done, like utilize this link for 5 minutes, 5 or 6 minutes, then I'll close it up. And after that, uh, if you have any doubts, I'm open to those doubts, and you can, just ask the question that you want to, and we'll end them. Okay, so basically, for the Google Gemini code that I shared, when it asks you to log in, like over there to verify your identity, over there utilize your Thapar ID or your college student ID, which is in the form of a Gmail, like whatever it is, utilize that, and then you will be able to get the access to Google Gemini or any of those accounts for free of cost, like without entering your credit card and all that. And if you don't have the access to it, then you need to verify your identity by uploading a proof. If it requires autopay, then just keep a track of when you have to cancel. Like you can cancel it after, like before. Yeah. If it's 2 rupees cashback, then enable auto pay over there and then cancel it before the next uh year. Like 3-4 days before the next payment cycle comes in. Okay. So everyone is done trying this link. Anyone still sorry, using it or wants to try something else? Any doubts that you guys have, you can ask, please. Online courses for ML. Okay, so you can go through the Andrew Ng's course on Coursera, like if you want to. If I'll share, this is the course, um, machine learning specialization. It's a decent course. Yep, but no need to, pay. I don't know this amount, like whatever the amount it asks you to. Just apply for a financial aid, and you will be done with it. Like this is something which I'll suggest you guys to do. Except for this, there won't be anything. Just lie on the application that you have a very bad house income. Like you can apply the financial aid using saying this thing, and they won't cross verify. You cannot get, student discounts in other platforms like ChatGPT or Cloud AI. Those are paid. You gotta pay somewhere like around $20, which is approximately 1,800 to 2,000 rupees a month to get OpenAI Plus or Cloud Plus. Okay, so that's it from my end. You guys have any other doubts? Let me know. Guys, any other doubts you have? I'm closing this link. Yep.
Okay, Ishkaran, anything else?
So that's it from my end.
Okay. So now we
Um,
और कुछ?
so they're having some doubts. Could you please tell this in more detail? Like, what do you want in more detail? Okay, so basically, for Coursera, you want to register for any of the course, there's always a app, like there's always a thing named as financial aid over there. Just click on the financial aid. It will ask you some questions, like, why is this course helpful to you and all that. Just answer those questions, and it will hardly take, 5 or 10 minutes. Answer those questions in the most sarcastic way you can. And by sarcastic, I mean you just need to lie on the application. Like, you can, everyone knows that you don't have a annual income of 1 lakh. So I declared that we are a family of like five, and I'm the only earning person, and I'm having a final family income of 1 lakh rupees a year. So I need this course so as to increase my skills and work upon them. So that's what I did, and they approved the application within 10 days. And once the application is approved, you have the course for like around 2 or 3 months. You can go through the course and get the certification for yourself. And the path to learn agentic AI fully with frameworks like LangChain and LangGraph will be that first, understand what actually LLMs is, because agentic AI is basically describing a agent as in, like, a person or a robot do one particular task, and that bot is powered by that particular LLM. So you need to have a basic understanding of what an LLM is. And uh, LLM isn't an LLM actually, it is actually a transformer. So what an encoder only model is and what a only decoder model is, you need to have a knowledge about that. So have knowledge about what exactly a transformer does, and then move to GPT and LLM models, and then you can move towards the end, towards graphs and graph neural networks, and then towards agentic AI. Any other doubts? Okay, so that's mine.
Okay, okay, Eishkaran, thank you very much.
Thank you so much.
So now, okay, class, everyone, thank you. I'm closing the session. Thanks a lot.